Hmm. So, very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 6th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 6th, our ongoing chapter, that is chapter number 3, force and laws of motion. And today we are entering into the session number 4. So far we completed 3 sessions, 3 classes to understand the force and laws of motion. That's 2 different topics, even though they are related. So we discuss, first session we discussed about what is force, various examples of force, and effects of force. What force can do. Then in the next class we discussed about what are the types of forces, like contact force, non-contact force, balanced force, unbalanced force, with various examples. Various types of force I told for you, like applied force, muscular force, magnetic force, gravitational force, electric force, frictional force, normal force, spring force. Many are there, right? All these are either contact or non-contact. Then in the last session, we entered to the laws of motion. That is Newton's laws of motion. So when a body is in motion, Newton studied about what is the cause of motion. So he came to know that cause of motion is force. So by using that particular concept, he proposed 3 laws, in which last class we discussed about the Newton's first law, which is commonly applicable in our day-to-day life also. Because a body which is at rest or continues to be in the rest only, or a body is in uniform motion, continues to be in the uniform motion unless compelled by an external force. If you apply force only, body moves from rest to motion, or moving body comes from motion to rest. That is a common statement given by the Newton, which is commonly we can observe any time. Okay. So why this is happening? Because that is the one kind of property, inherent property of the body. That property is known as inertia. So Newton's first law gave birth to a new word called inertia, right? So we study what is inertia. It is an inherent property of the body by which body cannot change its position. Body cannot change its position itself until force is applied. So we have seen various examples of inertia of rest, inertia of motion, inertia of direction. Even one example also you can see all 3 when you are traveling by bus. Bus example I told many times. And we discussed about all these 3 inertias, type of inertias with examples, right? Now, already we discussed about one more important term, momentum. Before going for second law, we discussed about the momentum also in the last session. So, momentum is denoted by P. P is equal to mass into velocity. Mass into velocity. Right? So, the momentum depends on mass or velocity. If mass increases, momentum decreases. If velocity also same decreases. So based on that, we defined the word momentum, product of mass and velocity. So the Newton's second law is based on this momentum word, right? That's why it also called as law of momentum. Law of momentum. You can see here. What second law states? Suppose see, when two bodies, a heavy one and light one, are acted upon by same force. One big body, heavy body is there and one light body is there. But force applied is same. For this also 10 Newton. For this also 10 Newton. Right. Same. For the same time also same is F and time is same. Suppose applied for 2 minutes. Right. 2 minutes. So the lighter body attains higher velocity for the higher speed than heavy body. What happened? This body will go with a great speed when compared to higher heavy mass body. Correct or not? It's a common sense. So what this second law states that, the laws of momentum state that the force is directly proportional to rate of change of momentum, mv minus mu by t. So, initially, suppose a body is here of mass m and with initial velocity of u. It is moving slight some velocity. We applied force. So, its velocity becomes m. No change, same only. Velocity becomes v. Increases. So, what is the initial momentum? M into u. Final momentum is m into v. So, what is change in momentum? mv minus mu. Final minus initial. Right? So time, it will take time for changing momentum. So that's why we call it the rate by t. Okay. mv minus mu by t. It depends on force. That is the statement of the second law. See here. The force is directly proportional to rate of change of momentum. Change in momentum by time taken. So mathematically it is given like this. mv minus mu. So I can take this. So you have taken m common here. So it becomes m into v minus u by t. But what is v minus u by t is nothing but a. So you can write f is proportional to ma, or f is equal to k into ma. Some constant. The k value is proved as 1 experimentally. So finally we get the formula. The second law, f is equal to ma, mass into acceleration. The famous law in physics for the force, which is the product of mass into acceleration. Right. So acceleration is directly proportional to force, and acceleration is inversely proportional to mass. Why? Because the force applied is more, acceleration also increases. If you accelerate the vehicle more, applying more force, body will go with a great speed. But when is there more mass is there, acceleration is less. So this states the second law of Newton, or Newton's second law of motion. Clear? F is equal to ma, which states that the force applied on a body is directly proportional to the rate of change of momentum. So from that we got the formula F is equal, right? So, force is measured in Newton or dyne. That is a unit for the force, Newton or dyne, right? So F is measured in, force is measured in Newton in MKS system or SI system, dyne in CGS system, Newton or dyne. Clear? Or you can write in other also, MA is there, na? Mass is kg meter per second square also you can write, or gram centimeter per second square, which is commonly known as Newton or dyne. Clear? So this is the Newton's second law of motion. Then before going for Newton's third law, let me show you one video on first, second law. Then we'll move to the Newton's third law.
Newton's second law of motion. Let's learn about Newton's second law of motion. There is an equation that goes along with this law. This equation states that force equals mass times acceleration. That means the mass of an object and the force pushing it determine how fast that object will move. Let's take another look at Newton's equation so we can break it down. The F in the equation stands for force. Have you ever thrown a football, pushed a swing, pulled a wagon, squeezed a sponge, or
All these are
twisted the cap
forces.
off a soda bottle? If you've done any of these things, then you have applied force to an object. Pushing, pulling, twisting, and squeezing are all ways to apply force to something. Sometimes people apply force to things, and other times different objects apply force to each other. But whenever a force is applied, there are always two things interacting. Now let's define the word mass in Newton's equation. Mass is the amount of matter or stuff inside everything, even us. All objects are made up of different amounts of matter. That means their mass is different too. For example, an elephant has way more mass than a cricket. On the other hand, a large balloon has much less mass than a small rock. Even though the balloon is a lot bigger than the rock has more mass because it is made up of more matter. Here's another example. A softball is about the same size as a cannonball, but the softball is lighter or has less mass than the cannonball. That's because the matter or stuff inside each ball is different, and what they are made up of affects how much mass they have. A cannonball is made from lead, which has a lot of mass, while a softball is made from cork, which has a lot less mass than lead. See if you can answer these questions. Which has more mass? A golf ball or a ping pong ball?
Ping pong.
Did you say golf ball? You're right. How about a bowling ball or a basketball?
Bowling ball.
If you said bowling ball, you're right again. Let's move on to the last part of Newton's equation, acceleration. Acceleration means a change in speed or direction. If you step on the gas pedal of a car, it moves. When you pedal a bike, it does the same thing. If you go off a ramp on your skateboard, you accelerate. Now that you know the definitions of force, mass, and acceleration, let's see how these things work together in Newton's second law of motion. Take a look at this baseball pitcher. He can throw a baseball very fast. But if that same pitcher was given a cannonball to throw, do you think he'd be able to throw it as fast or as far as the baseball? The answer is no. Do you know why? If you said it's because the cannonball has a lot more mass than the baseball, you're absolutely right. But it also has to do with force. Because the cannonball has more mass, it requires a lot more force to make it move or accelerate, like the force from a cannon. One more thing that is important to know about forces: they are either balanced or unbalanced.
We have seen already.
Look at these kids playing tug of war. Did you notice how neither side is moving, even though all the kids are pulling very hard? That's because the forces are balanced. That means that the forces on both sides of the rope equal each other. So neither side accelerates or moves. But let's see what happens if we put more mass on one of the sides. What do you think will happen now? The forces are now unbalanced. And because they're unbalanced, the side with more force is causing the rope to move or accelerate in that direction. Newton's second law is all around us, like in our example of the game of tug of war, throwing a baseball or a cannonball, and pulling a wagon with different amounts of mass. Take a look around and see if you can
All
find
examples.
any other examples of Newton's second law. Hope you had fun learning with us.
Right. So it clearly explained about the each and every point of the Newton's second law. Correct? So that is about the Newton's second law, which is given by F is equal to ma. Very important. Now we'll come to the last part of the chapter, Newton's third law of motion. Everybody knows about this. We are very popular. So for every action, there is equal and opposite reaction. What is the statement? For every action, there is equal and opposite reaction. So when you are hitting the ball to the wall, there is action. After hitting the wall, ball will come back because reaction is given by the wall. Like that, there are so many. For example, you are firing a bullet from the gun. So whenever bullet move forward action, the barrel will come back as a reaction. When satellite or rocket launches, you can see the ejection of fire. That is action, and rocket will go. It's launched towards the target is a reaction. So there you can see on spring also. When you pull the spring is action, release it, reaction. So for every action, there is a equal and opposite reaction. That is, action is equal to minus reaction. Both action and reaction are in opposite direction. That is the reason minus reaction will come. If suppose action and reaction acts on same body, body cannot move. So condition here is action and reaction should be on two different bodies. Two different bodies. Then only it is possible. Condition. So you may ask what happens if acts in one only, both. Both acts in one, body cannot move. Suppose one example I say. You sit in a bucket. Say this is a bucket. You sit in bucket. Comfortably you sit and try to lift the bucket. Can you lift the bucket by sitting inside the bucket? See what is action here? You are sitting in bucket, so your weight is action, acting in downward direction. Your weight. So you are pulling the hand in upward direction. That is reaction. So where they are acting, they are all acting on the bucket only. Bucket is the only object where action and reaction are acting. So bucket cannot move. Simple example, you are traveling by car. Car is stopped. Due to some reason, self is not working. So your father told, get down and push the car. So entire family came down of the car and you pushed it. So car started. But instead of coming out of the car, why can't you sit from sitting inside only? By sitting inside, can you push the car to start? Why? Because when you sit inside, you and car are the same body. When both are same body, action is on same body, reaction is on same body. So you cannot move the car. When you come out of the car, you are the different body, car is the different body. So that you can, that is very, very important condition in the Newton's third law. That is, action and reaction should be on two different bodies, not on same bodies. So hundreds of examples you can see for this. And most important law in physics, for every action, there is an equal and opposite reaction. See here. Whenever one body exerts force on another body, the second body exerts equal and opposite force on first body. The force exerted by the first body on second body is known as action, and the force exerted by the second body on first body is known as reaction. So it should be noted that action and reaction are just forces. So definition of Newton's third law. To every action, there is equal and opposite reaction. Action and reaction act on two different bodies. A very, very important condition. How they act simultaneously, we will not describe a simple experiment to prove Newton's third law. So this is a given here, spring experiment. tie spring to one end, fix at one end, other end you can pull. We can see change the force here. Action, reaction in spring balance. Right? As you are applying force, one spring, other spring also moves towards the reaction side. Same spring C and B. Clearly, you can understand how action and reaction takes place in spring. Similarly, there are so many are there. Acts on two different bodies, not on same body. That is very important. So some examples are given, you can see here for Newton's third law. How do we walk? The example number 1. How do we walk? How do you are able to walk on the floor? Because of action reaction only. Because we are putting the force action on earth or floor. It is giving reaction and making us to move. Action and reaction. When we walk on the floor, then our foot pushes the ground backward, and in return the ground pushes our foot forward. As you are putting the swimming, when you are doing swimming, also same. As you are putting the water backside with your hands, you are moving forward. Same thing given second example. So with the help of your foot is moving forward and your foot is moving backward, you are moving forward. That is the simple logic behind the walking or swimming. Swimming example is given, see next. All these are the applications where we can see the action and reaction. Okay, then why the gun recoils? When your bullet comes out, gun recoils. The trigger will come back. Why? Because of the action reaction. There is also one example. See here, the flying of jet aeroplane and rockets. So they fly because of the action will come downwards, and reaction, the jet rockets will go forward. Action and reaction. Even parachute or balloon, also hot balloon, how they are flying? Action, reaction only. And in case of boat and ship, when we are moving the water backside, ship will move forward. Action, reaction. So many examples are there where we can see this very interesting diagram. What they are showing here is a person, when the boat reaches the bank, he is jumping towards the shore. When he is jumping towards shore, boat will move back. You can check this. He is giving action in the forward direction, boat is moving in the backward direction. That is also because of the Newton's third law of motion. Same the case of hose pipe. Firefighters, right, directing a powerful stream of water on fire from hose pipes to put out the fire. Fire engines will come, no? Fire engine. That also action reactions. Horse pulling the cart is also horse pulls the ground backside with her 4 legs. With that, the cart is moving forward. So many examples are there. Flying of jet aeroplane, rockets, are the examples only. See, rocket. We'll see fire will come downwards, action. Fuel will burn, and the fuel produces the energy in downward direction and makes the rockets to move in the upward direction. Okay, these all are the very more examples of the Newton's third law. So we'll see one video on the Newton's third law before ending the session, right?
Newton's third law of motion. Newton's third law of motion states, for every action, there is an equal and opposite reaction. This third law always comes in pairs and is related to the force or push and pull upon an object. If you have 2 objects, one is doing the pushing and one is doing the pulling, no matter how little the objects are moving. And sometimes you can really see an action and a reaction. In Florida, at the Kennedy Space Center, scientists use rockets to launch space shuttles into orbit. When the rockets fire, the exhaust from the rocket moves downward while the rocket moves upward. Without this law of motion, the space shuttle would never have lifted off the ground, and we would never have landed on the moon. The force of action and reaction working together caused the shuttle to launch. You can't have one without the other. Want to see another example of Newton's third law? What do you notice? This time, let's slow things down and see if we can identify the action and reaction force. Did you notice that the cannon moved backward when the cannonball shot forward? That backward movement is the cannon's reaction to the action of shooting the cannonball, just like with the space shuttle. Newton also noticed that the amount of force on the first object always equaled the amount of force on the second object. In other words, the forces of action and reaction are always equal. That means if a boxer punches a punching bag with 50 pounds of force, that punching bag will also hit the boxer's fist with 50 pounds of force. Ouch! If the boxer only gives 10 pounds of force with his fist gets 10 pounds of force in return. And if he gives 5 pounds of force, he'll get 5 pounds of force back. So, if the forces of action and reaction are always equal, how do you think this is going to end? Oh, maybe don't try that one at home. Now that you know about actions and reactions, think about the many reactions we cause every day. Let's talk about one last thing. Have you ever tried to move a heavy piece of furniture like a couch? And did you wonder why it takes a minute for the couch to start moving? This is because of something called static friction. When you apply horizontal force from your body, the floor is actually applying frictional force to the same object. This continues until the object starts to move, and then sliding friction happens. Sliding friction is the same sensation that you get when you rub your hands together really fast and generate heat. You don't have to push something as hard to keep it moving when you reduce the friction. The less friction you have, the less energy you use. So, the next time you're jumping on a trampoline or even sitting in a chair, think about Newton's third law. Turns out there are actions and reactions happening everywhere you look. Hope you had fun learning with us.
So, hope you are understood what exactly the action and reaction, that is Newton's third law of motion. Right? So, this is the thing, this you can read and complete, you can complete easily all the mass into acceleration. Dash is equal to mass into acceleration. It is a force. Dash Newton is equal to 1 kg of 980, you can write. 9.8. The product of mass and velocity of the body is called momentum. Either you can go through each and every bit and you can solve them. If you have any queries, you can ask your teachers, because we have provided the complete solutions for each and every question in advance, right? So with this, we have done with this chapter of force and Newton's laws of motion. So we have first part we are done with force, second part we are done with the Newton's laws of motion. So totally we have done a chapter within 4 sessions, starting with the, just a minute, starting with what is a force, right? Examples of force. Next, types of force, right? Then effects of force. So this is the first part, force part. Then comes, we discuss about the Newton's first law, then Newton's second law, and finally Newton's third law of motion with examples. With all examples. Right? So many examples. Once you go through, you can understand that how frequently we'll come across Newton's laws in our day-to-day life. Everywhere you can see the Newton's first law, second law, or third law. But only thing is, you need to identify which one is first law, which one is second law, and which one is third law of Newton. Right? Hope you are done with this chapter. So after completing this, we're going to start the next chapter when you meet in the next class. That is our work, power, and energy. After knowing what is the force, we should know what is work, what is power, and what is energy. That is chapter number 4. We are going to start from the coming class. Next class that will be probably from on Tuesday, right? So that's all for today. Hope you understood. So spend some time to work on the today's chapter, maintain the notes properly, get it corrected. So that's all for today. Thank you, all of you. Have a wonderful day. Thank you.